Today's curiosity is aided and abetted by Arlington Amber Ale from Rendezvous Brewing Company. The company is based in historic Morden, Manitoba, a small town in the southeastern part of the province. There's no tasting notes or any other information on it, just the branding. So I was at a yard sale recently and I picked up all this stuff. It's all part of the same system, technology, I guess. It's an old technology that, let's see how many of you old-timers actually recognize it. Does anybody remember a system called X10? Some of you may be traumatized by the memories of the advertising from a company that used to sell this stuff, but the protocol itself is not that annoying. It's actually kind of interesting. So X10, the protocol, is a way of sending signals over the power line wiring in your house, or I suppose in a business or whatever. It was created back in the 70s, and basically it's an early home automation method or system. And it didn't just belong to that X10.com brand. There were tons and tons of brands who made stuff using this, and I've got 2 or 3 of them here in front of me. We'll take a little bit closer look at some of them. The basic idea is it encodes a 4-bit address and 4-bit data stream onto the power line using 120 kilohertz carrier, which is superimposed onto the AC power line. This Wikipedia article goes on to great detail about the various different bits and pieces of the protocol. I'm not going to go that deep. If you want to, I'll link this article below. But let's take a look at some of the stuff that I've got on the bench. That's the more interesting thing today. So here's the majority of the things that I got in that. There's a few other duplicates that I've left off just for space, but basically we have these transceiver modules which receive an RF signal from one of these little wall plates, which is just a little wall plate. It's got a battery in there, good old 2032. It receives from there and then it transmits over that power line to one of these guys, which causes things to happen. There are replacement outlets. There are Decora style switches. There are this kind of switch which fits behind the standard classic old school faceplate in the North American system. These two are different only because one is a 3-wire, so it's for a 3-switch or a dual switch 3-way system, or the standard 2-way switch. There are lamp modules, and there's a couple of different brands. They all interoperate just because they all use the same standard. The lamp modules are different from the appliance modules in that usually the lamp modules are only for incandescent lights because they're using triacs. The appliance modules are using a relay, so they should be able to control literally anything you can plug in that won't blow your circuit breaker. And then there is this one, which is a remote controlled chime, is what it calls itself, a doorbell chime or something like that. There are, or were, a lot more different things that you could do with this. There's a more modern variant on it, which is backwards compatible, but also allows 2-way communication. I don't believe any of these are new enough to deal with that. You notice on all of these modules, there's 2 dials to set them, or almost all of them. There is a house A through P and a module 1 through 16. Now on the transceiver units, there's only a house. So it is receiving commands or addresses through there. It adds its house address. So basically 2 levels of addressing. So that if you're in an apartment building or something like that, you could set it different from your neighbors and it wouldn't interfere. Or you could set multiple house addresses in your house if you wanted more than 16 devices. For teardown purposes, I think I'm just going to focus on the common lamp module. Let's choose the powerhouse one and the transceiver module. All the rest of them are going to be basically the same guts. The only difference is, like I said, in the appliance module, it's going to have a relay, and then it's just the form factor is the other difference. So let's start first on Mr. Appliance module. I'm seeing two little Phillips screws buried deep down in holes, so let's pop them out and see what I find. So there it is, popped apart. There was just some clip action down there that I didn't know about. So there is the two little dials. Well, that's just a decorative ring from the front of the dial. Okay. So nothing too special there. But it does have 3 wipers on one side and 2 on the other side. And over here it looks like there's 1, 2, 3 different layers of track that it's dealing with on each of them. Yeah, I guess that's enough to get 16 positions, isn't it? Sure. Anyway, those all seem to go over here to, looks like a dip on the other side. Okay, let's see if we can dig in any further here. So I think I'll just push, yeah, there we go, push on the prongs, and that comes out. Ooh, big heat sink. Okay. What's connected to that heat sink? BTA 1.0, 400 degrees Celsius. Absent any other information, I'm going to guess that's the Triac doing the switching. Then we have 1 chip down there, a couple of transistors, and the rest of it is all just passive stuff. Because this thing's filtering a frequency out of the power line, I'm not surprised to see that inductor there. A lot of these components are pretty tight in here, so it's hard to get any values off them, but I'm gonna guess that capacitor there is probably part of power supply in a capacitor dropper kind of a way. There's a little diode down there beside him. Couple of electrolytics. Let me see if I can get any part numbers and see what they are. Yeah, as suspected, that BTA10 is in fact a Triac, a 10 amp Triac, which well exceeds the capacity that this device is rated for, so good on them for that. And yeah, that makes sense. So there is the gate of the Triac coming from over here in digital circuitry. There's one of the MTs going to that output pin. There's the other MT coming from this wire, which comes from over here on this input prong. This chip, however, is proving elusive. The only reference I can find to it is on websites from decades ago that were doing exactly what I'm doing here, tearing these things down. The assumption is that it's just a purpose-built custom chip just for doing exactly this thing. Which makes a certain amount of sense. These things were mass-produced in huge quantities. One other oddity in here is this guy back here, which is just zip-tied onto the heatsink. But what it is a series inductor. Here's one wire coming out to one of the output pins. And the wire on the other side comes from this input pin here. There's not much else going on. It's just a series inductor. Since this is a Triac-based switch, I don't think we got a lot of inductive stuff happening downstream, especially since it's a lamp module and it's not supposed to be used with anything else. But I think what it's doing is blocking the X10 signal from progressing further down the line. I think. I don't know. I could be wrong. But other than that, it's basically just doing exactly what we thought, creating a little power supply. It's got a little filter here to filter out the signal. The signal's being processed and whatnot on that chip. The chip is connected to the address switches on here. And then there's one line from the chip, goes out through a diode and resistor and transistor and whatnot, and ends up on this line, which goes to the gate of the Triac over here. It also looks like somebody's been into this one. There's a couple of extra shiny bits over here, like somebody's been soldering more recently than when this one came out of the factory. Interesting. Also really funky is the hand-drawn squiggly traces for no reason other than just artistic merit, as far as I can tell. That's how stuff was done back in the 70s, you know? Now, same again with the transceiver module. I don't know how much different it's going to be because it also has an output on it. But other than that, it will have the RF receiver for this, which is, I think, 310 megahertz is what I remember from the Wikipedia article. Oh, it comes apart that way. Okay. Well, we do have quite a bit more going on in here. Although, down on the bottom board, we have a similar inductor, similar capacitor for power supply, another transistor in there, another chip down in there, and this particular one just has the label on a piece of tape on it. But then we look closer at the top board and we find a whole bunch more RF-ness and some hot glue. But there's more inductors and capacitors, and it's kind of hard to see back in there in the shadows. But it has all the hallmarks of an RF board, which of course makes sense when you got one of these on the side of it. The other curious thing is this one seems to have a set of relay contacts on it. So there is this little wheel here, which looks like it's something, the solenoid grabs it and clicks it around like that. And with each time it moves one step, it opens or closes the contacts. So this thing can latch into its position, and if the house loses power, it will come back up with that connection still, or with that switch still in whatever its last position was. That's pretty neat. So we got that same arrangement there for the addressing switch, although this one only has a house address because it's passing on all 16 device addresses. There's a little bit of adhesive there and a bit of hot melt that was kind of holding it together. And then the antenna connection is just a piece of foil tape on there. And the antenna sits on the other side of a piece of plastic there. So that is capacitively coupled, inductively coupled, non-contact coupled, so that there's no possible way for the antenna to become electrically hot. So I'll just take a moment to put these back together. Not that I need to, because I have duplicates of it, but still, I'm going to do it anyway, just to have them to play with. Let's see if they still work. One moment or two, please. Actually, before I fire it up, I'd kind of like to see what's inside one of these little wall plate transmitter units, because I don't see any way on them of setting the house or the address or any of that stuff. So I wonder just how they do their thing. Oh, while it is 4 buttons on the front, it's actually 8 buttons. There's looks like maybe an on and an off for each one. Well, there's really not too much to this, is there? There's the tracks where the push buttons go on. There's a wee chip. We got an LED. What is that? Is that a capacitor? More capacitors. What is that little device there? It doesn't appear to have a designator on it, but it does look like it's got a ferrite slug. If you flip it over, there's a little adjuster there. So I'm going to guess that that is some sort of variable inductor, which with these capacitors would probably make some kind of a filter. I got one transistor there. That's the only active component on the board other than the chip. And I'm going to guess that that chip is another one that is purpose-built just for this, proprietary and not findable. But I will try. One moment, please. Yeah, as I suspected, no dice on that one. Not even vague references to it. But when I was looking closer, I noticed that this little guy is actually 2 components. It is a capacitor and an inductor in parallel with each other. One side's on the ground trace, which is what that one is, and the other side is connected into this suspiciously antenna-looking trace here. So those going to ground, and this guy here with these capacitors here, that is clearly the RF portion of this circuit, or at least the RF tuned portion. And I don't know where the actual oscillation is set up, but it's entirely possible that inductor, those two capacitors, that transistor, and some of these other capacitors forms a small oscillator in there. And then this line here coming from the chip is coming in to influence that, just to modulate it. So now I guess the thing to do would be to set up a couple of these and just see if they actually work. So I'll plug a lamp module into one of these, into my power bar, plug one of these transceiver modules in. These aren't the two that I took apart. These are ones that haven't been molested. I think I'll set them both to house A. Does that say house A? Yeah. And house A on that one. I don't know what's going to happen, but we'll plug them in and see. The power on there. I guess there's no lights on these. Let's see if this one's built-in switch happens. Oh yeah. You hear that? Let's plug a lamp into it just to... Oh yeah. So that's that snap contact that's going on in there, right? I don't know how you would command that one though, because this one doesn't have an address, a device address. Okay, we'll plug into this one. That's turned on right now. That is device 3. Oh, hey. It's working. There's a delay to it. But it's actually working. I did not expect that. I wonder if it'll work any better if I put a fresh battery in it. Maybe it's just weak because that's ancient. So again, that was device number 3, I said, right? Well, it just seems like there's a delay. So it doesn't seem to be all that reliable in the RF path unless you're ridiculously close to the thing. Well, I suppose you could slap this on the wall right above where this is plugged in or something like that, but it doesn't seem all that useful for whole house control. Let me just put a fresh battery into a different one of these. Yeah, that works from there. Does it work from a couple of feet away? No, it does not. You literally have to be within arm's reach of this thing for it to work properly. Well, that's definitely a limitation that I hadn't foreseen. All right, things are escalating here just slightly. I've added the appliance module to another cable that's all attached to the same AC circuit. I've set this one also to house A, and this is set to device number 2. And when I push device number 2 on, that happens. When I push device number 2 off from a different control panel, that happens as well. So it seems like this guy is responding the way you'd expect. Another thing that I discovered is when I push button A, the relay inside this transceiver module clicks. I don't have anything plugged into it right now, but actually, hang on. Let me move the lamp over there, and then we can see that that is in fact number 1. Okay, so that solves that mystery. So we have 3 devices connected right now. That is number 3. Right. I want to find out how you would reprogram this to a different house code or to different unit codes. Let me do some Googling and I will be back in a moment. After a surprisingly short amount of time, I found this, which seems to be exactly what we want. You just long press and hold the buttons and watch the flashing light to set both the house code and the unit code. I found that because there are still people selling these things new. It is still something that exists in the world. And there's the manual that I found there. Did not expect a whole array of these things to still be available. Like all kinds of stuff. There's a couple of the switch modules that we've got. There is one of the outlet modules we've got, or something very similar. There's a couple of other wall switches we got, one of those, and this guy right here. Oh, and these annunciators too. But first, let's see if we can reprogram one of these wall units. So it says press and hold the right side for unit selection until it stops flashing. And then it will flash to tell you which unit it is. So I'm going to go 1, 2, 3, 4. And wait for it to flash again, I think. There we go. So now nothing responds to this because it thinks it is number 4. So let us change this guy to be device 4. Plug him back in, and now that should... Ha ha ha! Wow! It's a little clunky, but the system still works. That's awesome. Well, okay, it works except for you have to be right on top of the antenna of the transceiver for it to work. And then there's this little chime unit. I'm guessing that it responds just exactly like any of these other units does. So I've set it to unit 2, house A. Oh, okay. So, oh yeah, there we go. Okay. What happens if I push the off side? Nothing. So it's just the on. So I guess you would need some kind of a trigger device by your door to cause that to happen and let people know, sure, why not? So I suppose one other thing you could do with these, if you don't want to use them in their native form factor, is to strip out everything except for the power supply section and the triac and put some kind of a ESP32 or ESP8266, probably an ESP8266, probably like an ESP01 in there, and then you could probably use Home Assistant or something like that to control them. Or I'm sure there are projects out there for integrating into this guy to send the signal from a microcontroller or something, and then you could use the power line side and not have to modify these modules. I'm going to have to look around. If I find anything, I'll put some links down below. That's kind of beyond the scope of this video right now. I just was curious about these things. Well, that was an interesting exploration. I remember seeing these things back in the day and thought they were kind of a neat technology, but I never once got my hands on them until, like I said, I found this whole bag full of them at a yard sale. So, yeah, thanks for watching. I hope you found that interesting, maybe nostalgic for one or two of you old gray hairs like me. Yeah, questions and comments down below. I'll throw a few links to stuff down there as well, just for interest. Some of them will go to commercial sites. I have no interest in those. They just happen to be the ones that I found. Anyway, thanks for watching. As I said, talk to you later.